Okay, so in this lesson, we're going to go ahead and study Boyle's law. So Boyle's law is basically stating the relationship between volume and pressure. Okay, so Boyle's law is the relationship, abbreviate this, between, just abbreviated, volume and pressure. In other words, how does changing the volume of a system affect its pressure? Okay, when we're dealing with Boyle's law, it's important to understand that we are assuming that this system, in other words, what we're dealing with, has a constant temperature. Okay, so in order for Boyle's law to hold true, we must have a constant temperature. So let's look at a scenario. So let's say I have a container here. In this container, I have a piston. So this is what you find in cars. This is a moving piston. So it's basically the top of the container which can move up and down freely. Okay, so I have a certain volume right now, right? This is my volume. So I would call that, I'm just going to say V1. That's my first volume. Let's say we have some gas particles within this. Right, we have some gas particles. They're in there. Okay, so these gas particles, according to the kinetic molecular theory, they're moving. And we know that they're colliding, and these collisions cause there to be a pressure, which we'll call P1. So there's a certain amount of pressure in here, which we'll call P1. Let's take the same scenario, but now I'm going to push down on this piston, and I'm going to compress it. Okay. In other words, in my second scenario, it's going to look a little something more like this, whereas my particles are now much closer together. Okay, make sure I have the same amount. Yes. Okay, so they're still moving, they're still colliding, exerting pressure on the container. So I have a new volume now, right, which I can refer to as my V2, my volume 2, because V stands for volume and P stands for pressure. So this would be because I changed the volume, I'm changing how close they are. I'm changing the amount of collisions, right? So there's more collisions now because things are closer together. So I'm changing my pressure as well. So my pressure changed. I'm name that P2. Okay, so let me actually turn this light on here. Okay, so now if we look at this system, well, first, so when my volume went down, things got more compressed. They were able to bounce more, right? They're gonna collide more against the container. Well, if we have more collisions, what does more collisions equal? Well, more collisions equals a higher pressure, because pressure is collisions, right? So when my volume goes down, things bump more, and I have more pressure. That's all it means. Okay. So let's look at the opposite way, though. If I'm looking at the opposite way, well, when my volume goes up, when things get bigger, I can move around more, and I don't have as many collisions. So if I don't have many collisions, then my pressure goes down. So that's all Boyle's law is stating. Boyle's law states that when volume goes down, pressure goes up. When volume goes up, pressure goes down. They're inversely related. Okay, so this system here, this first scenario, it has a certain energy, right? So if I go P1 times V1, they have a certain energy, which I can call K. It's just this constant energy according to molecular theory. Okay, so let's say this next system, well, they also have that same amount of energy because energy is never created or destroyed, right? Which I can call P2, V2. So they're both equal to each other. So that's where we come up with the equation for Boyle's law, which states that P1 times V1 is equal to P2 times V2. Okay? So in other words, if we multiply the beginning pressure and volume, it should equal the multiplication of the new pressure and volume. And we can rearrange this equation to solve for anything. I'll do one example. Let's say I want to find the pressure of a new system, or I want to find the initial pressure of a system, and I'm given everything else. Well, if I want to find this, and I need to get this to the other side of the equation, so what's the opposite of times V1? Well, I divide by V1, right? It's the opposite of that. So divide by V1. In other words, this cancels out. P1 equals P2 times V2 divided by V1. Okay, let's go through some examples, and I think this will start to make a little bit more sense for some of you guys. Okay, make sure I have enough light in here. Okay, so let's go ahead and work through some examples. So here's the first one. So it says, a gas whose initial volume is 20 liters has a pressure of 1 liter, of 1 atm, 1 atmosphere, and is compressed to a pressure of 2. So this will be my P1, right? My V1, my initial volume. Let me rewrite that there for you guys. V1. This is my initial pressure. So this is my P1. I increase the pressure in that system. Well, if it has more pressure, then the volume must be lower, right? That's my P2. And V2, that's what I'm looking for. Okay? So let's remember the equation. P1 V1 equals P2 V2. Okay? I'm just going to plug everything in and then solve. So I know my volume 1 is 20. So 20 times 1 is equal to, well, my P2 is 2, so 2 times V2, right? I want to solve for that, so I need to get this on the other side. So I need to divide. Divide by 2, divide by 2. This cancels out. My volume is 20 times 2 divided by 2. Well, what does that give me? That gives me V2 equals 20 divided by 2, which is 10. Okay? I didn't put units in this problem, but if we're looking at units, well, let's think about it. So also before you start these problems, the units have to be the same. So if I have ATM here, this has to be ATM. If not, then I need to change that. Okay. If I started with liters, well, my unit is going to end up in liters. If I started with milliliters, then my unit would be milliliters. Okay. So whatever you put into that equation is what's going to give you. And I'll go over why in terms of units in the next problem. Okay, so let's say, next problem. An ideal gas occupies 2 liters. That's going to be my volume 1 of a flask at a 760 torr. Okay, so that is my P2. That's my second pressure, right? This gas is allowed to expand to a volume of 6. Calculate the final pressure in torr and ATM. Okay, so this problem's asking us for two things, right? First, we're going to end up solving in torr because that's the unit that's given to us. So let's just plug everything in. So I have 760 torr, we'll put the units in for this one, times 2 liters, right? Is equal to my second pressure, which I don't know, times my second volume, which is my V2, which is 6 liters. Okay, so I want to get this to the other side, so I divide by 6 liters. 6 liters, cancel, 6 liters. So that's my pressure. And the reason we're ending up with torr is because if liters are on top of each other, they cancel. Okay, so I go 760 times 2 divided by 6. Okay, so I go 760 times 2 divided by 6. That's going to give me, we'll round to that first decimal. That will give me my P2 equals 253.3 torr. Okay. All right. If I wanted to, I could turn this into ATM. You have to do that for some problems. I'm not going to go over too much the conversions, but because you would just convert this into ATM, now you would have 2 answers. Okay, but I don't want to go over conversions in this video. Okay, let's go to the next problem. What would be the new volume if the pressure, so we're looking for the new volume. Okay, so if the pressure on 600 milliliters, so 600 millimeters, that's my V1, my initial volume, is increased from 900 kilopascals to 150 kilopascals. Well, this is what I start off with because it increases to that, right? So that's my P1. This is where it ends up. So that's my P2, my second pressure. Okay. So we're looking for my new volume, which is V2. So that's what I'm looking for. So let's plug in what we know. We know pressure 1 is 90. I'm going to leave out the units for now. Times my volume 1 is 600 is equal to my pressure, my second pressure, which is 150, times my V2, which I don't know. Same thing we've been doing. We divide this side by 150 to get V2 by itself, divided by 150. Cancel. Volume 2 equals 90 times 600 divided by, actually let's multiply that first. So it's divided by 150. Okay, that gives us 360. So my V2 equals 360. Okay, so the reason I left out units in this one is because you can find the units simply by looking at the problem. Okay, well, if I'm looking for volume, in my problem I used milliliters. The volume was in milliliters, so that's what my units are going to be for the end, milliliters. So we just got to look at it at that. Okay, if I was, for example, looking for pressure, well, if I used kilopascals, then my unit would be kilopascals for pressure. But because we're doing volume and we use that, that's what we end up with. Okay. All right. Let's look at a new problem. So it says, in this problem, we have, so the pressure of 6 liters of a gas is 200 kilopascals. So that's my P1, right? That's my P2. Sorry, that's my V1, and that's my P2. What will the volume be? So I'm looking for V2 if the pressure is doubled. Okay? Keeping the temperature constant. The other ones didn't say the temperature was constant, but if it doesn't tell you the temperature changes, you can assume that it's the temperature staying the same. Unless they tell you that it changed. That's a different type of problem. Okay, so there's a couple ways to look at this. I know pressure and volume are directly related. So if my volume, or rather, if my pressure goes up, I know that my volume has to go down. Okay? In other words, if this goes down, if my pressure is doubled, if I go 2 times the pressure, then my volume should be half of that. In other words, my volume should be half of that, which would be 3. Okay? Let's test that out. It says the pressure is doubled. So that means this is my initial pressure, right? But now it's 400 because it's doubled. Kilopascal. So let's test out. I said the answer would be 3, right? Okay, so here we go. 6 times 200 equals 400 times my V2, which is what I'm looking for. Divided by 400 to both sides. Cancel. Plug this in. That's going to give me 6 times 200 divided by 400, which is what we had said before, 3. So V2 equals 3. Well, what's the volume? It was in liters, so my units are liters. Okay? And that's going to be it for the practice problems.